All right, so this says unit test, but this is just a review that we're going to do together. There's a lot of basics on here. There are some errors, some typos on here, but I was only able to download it as a PDF. It was from another site, so I couldn't change anything. So we'll change it as we go. So first question says, only matrices of the same dimensions can be added or subtracted. And that is true. When a matrix is multiplied by a scalar, its dimensions will change. It's false. Which of the following could be considered an identity matrix? It's both of them, right? One of them's just a 2 by 2, and the other one is a 3 by 3. So, Caitlin, in answer to your question earlier, if you multiply a matrix and its inverse, you should get something that looks like this. Okay. All right. Which of the following products would be undefined? So, the way that I would do this problem is first go through and write down the dimensions of all the matrices. So what size is matrix P? It's a 1 by 3. And what about Q? It's a 3 by 1. And R? A 2 by 3. Okay. So a PQ would be 1 by 3 times 3 by 1. Is that working?
Yeah.
Because the inner dimensions are the same. Okay. So then we have QP. We have a 3 by 1 times a 1 by 3.
That's good.
That'll work. Hey, what will you get the same matrix though if you multiply PQ and then QP?
No.
Because multiplication is not commutative when you're dealing with the matrix. All right, so far we're good. What about PR? A 1 by 3 times a 2 by 3. That one won't work because the inner dimensions are not the same. So that's how you know that you can multiply. All right. Matrix addition holds true under which properties? I agree with you. A works. That means that A plus B is the same thing as B plus A. Is that it? What is association? Okay, so I actually have something like this. A plus B plus C, where I can do A plus B first, plus C. Is that the same thing as that? Yeah, so actually it's D. Both properties work. Doesn't matter how you add, you're going to end up with the same sum. All right? This one obviously has an issue here. This would be false. I don't have a choice. Matrix multiplication holds true under the commutative property. That's false. What that says is that AB does not equal BA. AB does not equal BA. Multiplication is not commutative with matrix operations. Okay, what are the dimensions of that matrix? That's a 2 by 3. It says add and clearly has a subtraction sign. So this might be something you'd have on your quiz with a little bit more, maybe with a scalar in there somewhere, but what would you do on this? Subtract corresponding elements. So -3 minus 2. Well, this is easy because we only have one that will work, but if you're doing it yourself, obviously you would finish it out and write the whole difference down. Okay. Any questions on this page? It's really easy. Okay, what about finding the determinant? I want you to practice just to make sure that everybody understands the keystrokes for finding a determinant. You've got a problem like this on your quiz tomorrow, and it really is as simple as putting it in your calculator and giving me the answer. You don't have to show your work. Now, when we get to vectors, I'll make you do the bottom right, 4 corners, bottom left. But for your quiz tomorrow, you just put it in the calculator. That's easy, right? You do? You don't? Let's practice. You have your calculator out? Yeah. Let's practice while you're done. Okay, well, let's do it. Okay, well, let's do it together then, because you need to know how to do it. You don't want to have to do these by hand if you don't want to. So let me pull up my calculator. Hold on. Okay. We've done these. We did them in the calculator. Okay, what size is this matrix? 3 by 3. Okay. Bella, what do you call it, the numbers?
Oh. -1.
Oh, thank you. -1.
-2.
-2.
3.
3.
-2.
-2.
-5.
-5.
4. 4.
0. 0.
5.
5.
1.
1.
Sorry, Bella.
Okay. Is that it? Okay, so y'all can, you know how to get it in the calculator, right? Okay, so second quit, get out of that menu, and then go second matrix math. And the very first option is determinant. So pull up determinant, recall matrix A. Well, that must not have been where I put it. Where did I put it?
Matrix A was a 2 by 3.
Yeah, but where did I put? Let me go back and see where I put it. Second matrix. I put it somewhere else. I must have put it in C. Okay, so second matrix, math, determinant, second matrix, 3. I wasn't paying attention where I put it. There we go. -9. So we got that simple. Okay? And yeah, you can certainly, I mean, if you know how to do it by hand and you want to do it that way, you'll certainly have time, but much easier in your calculator. When we get to vectors, you will have to do it by hand, and you will have to do it with the bottom right 4 corners box left. But until then, you can do it the easy way. So, all right. So this answer is -9. Okay. Inverses. So I discovered earlier today that there's a little bit of a misconception about the process for finding an inverse. The very first step that you do should be finding the determinant. To make sure it even has an inverse. So to find the determinant of this, I would say 3 times 3 minus 2 times 5. Okay, the process for finding an inverse by hand is to do 1 over the determinant, whatever it is, times, and now you need to rearrange that. Okay, so you rearrange this one and this one, it's just they're the same this time. So, and then you make this one negative and that one negative because they were both positive. Okay, now you do scalar multiplication. Well, if we just got the determinant to be -1, right? Yeah. So that what I'm multiplying this by then is -1 times all of those. So -1 times 3, -3. -1 times -5, -1 times -2, and then -1 times 3. So it's C, correct? Right. You absolutely can put it in the calculator, but how do you do that?
You have to, it's second matrix.
So if I go back here and pull up my calculator, do you see the matrix key that you usually have to push? Well, don't do the second. Just hit that key. So pull up. I can only do it with my matrix C because I'm only doing the square ones, and that was where I put my square one. So if I did that one, I would pull up matrix C. So I'll do 3. And if I wanted to find the inverse of the one that we had a minute ago, I would do this. And I hate the way that looks, but I can change it, can I? Yep, math, fraction. And now they're all pretty and exact. I do like it. Okay, and that's the way they're going to want you to do it in WebAssign too. I know there's a question on WebAssign where the answers come out to be decimals, and a couple people have tried to put them in that way and it didn't work. So make sure you do the math fracts.
So when you do that, all of that finds the determinant.
So, okay, girls, when you use the calculator to find the inverse, it's already programmed to switch all the numbers around in the matrix and multiply it by the scalar. Okay, it's only if you do it by hand that you have to put that up. All right, back to,
In a calculator, you wouldn't have to find it.
no, if you do it in the calculator, you just put the matrix in and hit inverse. Yeah. Okay, so let's, with that question in mind, let's do number 11. See, I see you guys entering a matrix. You're supposed to be finding the inverse. What's the answer? What's the inverse?
Undefined.
It's undefined. There was no reason to even put that in the calculator. Why? Because the determinant is 0. Do that first. I saw you all putting it in your calculator. You're arranging it fine, but do the determinant first. The determinant is 0. So if I was going to find the inverse using the determinant, I would have to do 1 divided by the determinant, and 1 divided by 0 is undefined. It's not 0, it's undefined. So you can't do an inverse if the determinant is 0. Which brings me to my next question. That matrix is called what? It is square, but it has no inverse, so it is singular. A singular matrix has no inverse. A matrix with no inverse that is singular has the determinant of 0. Okay, if I want to solve this system, this is a linear system, what would I do as my first step? I would rearrange the order of the first equation. Okay, so when you make a system of equations with matrices, you want to make sure that your x's are lined up vertically and your y's are lined up vertically, etc. That brings me to a question in WebAssign. If you have a variable that is missing, what do? 0 placeholder. But you have to make sure that the variables are aligned vertically. So be careful that you do that first. Don't assume that the second variable that comes along is going to be y. And that is, I think, a question in WebAssign. All the letters are kind of misplaced in position. So do this first. Change the order so that you have the x's vertically, the y's vertically, the z's vertically if you need z's. And then anything that is missing, use a 0 as a placeholder. And I also know that WebAssign is telling you in the directions to use the inverse to solve. You guys can ignore that direction because what did I teach you to do? RREF. All right, so just for practice, help me set this up as a matrix. Wow. Help me set this up as a matrix. What would I do? You have to move the 7 over, and when you move it over, it becomes negative. So this would be negative 7, 2, 18, 6, 6, 0. Okay, now, when I put this in the calculator and I do RREF, I'm going to get what on the left-hand side? I'm going to get an identity matrix. So it's going to look like this. And then it's going to have 2 numbers right here. Those will be your x's and your y's. And so here's how you can give me that answer. You can either write it like this, x equals y equals, or there's one other way you could write the answer. Coordinates as an ordered pair. Because that really is the point where those 2 lines cross. So an ordered pair would be completely appropriate. Somebody do this one for us real quickly and tell us what the answer is. Just, you ought to do it for practice. And remember, it's RREF, not REF. What'd you get? Negative 2, 2, I think that's correct. Negative 2 and 2. And so I could write my answer like this. Or I could write my answer like this. Not just a -2 and a 2 out in space. Give them some sort of a definition. Okay? All right. Next. All right, these are ones that we don't have to do together. I just wanted to point out some things about each problem. So on number 13, that's a multi-step operation. What should I do first? So I should do this part first, right? So scalar, then add. Okay. What about number 14? You have to add first, then scalar. So order of operations is still what you use. Okay. What about number 15? What should I do before I even try a multiplication problem? Now this one's kind of obvious, but
See if they're the same dimension.
make sure they have the same dimension. So what will this yield? A 2 by 2. And I would put this in the calculator. And remember, we learned the other day that you have to use a multiplication symbol to get the calculator to multiply, or else it gives you an error message. Will this one work?
No.
Well, what size is this? This is a 3 by 2, and this is a 2 by 2. Inner dimensions are the same, so what will it produce? It's going to produce a 3 by 2. Start out by writing down what your dimensions are in row by column, then do your operations. Don't waste some time just automatically going to the calculator and then realizing, oh wait, I couldn't even multiply that to begin with. Okay. Determinant of a 2 by 2, easy enough. What do? Cross multiply and subtract. All right, these are so easy, it might not even be worth your time putting them in the calculator. So you would do 30 minus 63 negative 33. Okay. I would put the 3 by 3 in there, unless you just want to do it by hand. But you know how to do it now, right? Then go to the math menu and the matrix menu and then hit determinant. All right, so the other thing that I wanted to point out, just to remind you about, is the notation. This trips people up every year. These are not what? They're not absolute value symbols. They mean determinant. Now over here, it's in brackets because it says find the inverse. And what key am I using again? So if I put that in matrix A, then I would do call matrix A up and then hit that inverse key, so -1. All right. Same on those two, and then solve by matrix method. Anything I need to do to get that one started? Not at all. Let's just set it up. We don't have to answer it, but let's set it up. 4, -1, 10, 2, and 6. And then you're going to do RREF. Even though WebAssign says use the inverse, you'll use RREF. Okay, any questions about any of those? Well, I bet you're going to have a question about number 1. Yeah. So did you find it? I'm not sure. Is it on the practice one or the? Okay, so on the assignment sheet, find number 1 and let's do this together. You got it right? Yeah. Awesome. So the reason that students have struggled with this today is because they're trying to do division in a calculator with the matrix, and you can't do that. You could do multiplication by a fraction. It's the same thing as division. But let's just walk through the steps and I'll show you just really how easy this is. So this is the initial problem. Okay, now think algebra. What operation could I do first? I can do addition first. Did y'all ever stop to think that when you're solving an algebraic equation, you do PEMDAS backwards? You know what PEMDAS is, right? Please excuse my dear Aunt Sally. All right, well, when you're doing solving an equation algebraically, you have to do PEMDAS backwards. The last thing you would do would be division or multiplication. Whereas when you're solving an equation, the first thing you would do would be division or multiplication. So you always do it backwards. So the first thing I can do is addition. And so what I did is I just rewrote this. If I want to add this whole matrix, why am I adding it, by the way? because it says subtract, and when I make a movement over the equal sign, I do the opposite operation. So my first step then is to add these two matrices. All right, and now this is what I have. Do you agree? So I've got a -8 and a -22 that gives me -30. The two -5s give me -10, -8, 37, give me the 45, and the -4 and the 14 give me 10. Okay, so I know what you want to do is you want to put that matrix in and divide it by 5. But you can't do that with a matrix. However, if you really wanted to do it in your calculator, you could do scalar multiplication times what? -1/5. You could do scalar multiplication times -1/5. Or you could take the really easy way out and just divide each of those elements by -5. And that's your answer. That wasn't too hard.
Is that what you're talking about this one?
There's a high likelihood, yes. That's why I wanted to make sure that you had all these worksheets with a variety of things on there. I got one more for you. Number 3. Actually, I've been most impressed today because there are really 3 methods to do this, and I did not think that students would come up with one of the methods, but I had a student come up with the other method during second period, so we'll see what you guys can come up with. The first method the first period came up with is trial and error, and that works. Trial and error works. It's a valid problem-solving method. There is a better way to do it, and that would use the calculator. And I'll see if you can get to that method. And then there's a third way to do it that I had not even thought about that I had a student do. All right, so we're looking at this question, and I know what was confusing to begin with. When we first started learning about matrices, I said that a capital letter is what you call a matrix. So that A that's at the end, that is a matrix. That's not a scalar. So I'm looking for matrix A that will satisfy these conditions. Okay. Well, let's clean it up a little bit. Can you see what you can do algebraically first to do a little bit of simplifying? Okay. So I can add these two? No, I can't. But I can move this one over here. Okay, so if this is addition, then I need to subtract. Okay, so are we all okay with how I got it 16, 8, 7, 1? And then I rewrote this. With me so far? Okay. I rewrote this so that I was reading it from left to right instead of from the right to the left. So what I did is I said, okay, here's the matrix that I know, and I just called it B because that was already called A. Times some matrix A should give me 16, 8, 7, and 1. And I labeled them A, B, and C. Okay? Well, get away. One way of getting this answer is by using what you know about matrix multiplication. How do you multiply with 2 matrices? Row by column. So work it kind of like, if you're going to do trial and error, you would have to do like a Sudoku puzzle, where you start somewhere and then work backwards to try to fill in the other ones. It's a valid problem-solving method. It might take you a while, but I had a bunch of people in first period who came up with the correct answers by using that method. Is there any other way that you can think of that you could use your calculator and a property of matrices to solve this? I could put it into an equation. All right, how do you want to do that? You're right. That was the method that a student in third period came up with today that I didn't even cross my mind to do it that way. You could put it into an equation and solve. Is there anything else you could do? Well, you have an answer? Well, try it. You try it with an equation, and let's see if you can come up with the right matrix. Anything else, Cameron?
Okay, I tried putting it in an equation, but like, I get stuck because you can't divide a matrix, you know?
Mm-hmm. You're right.
And so, yeah, I'm kind of like stuck there. I don't know how to.
Can you multiply it by like You put 1 over. Did you put it over matrix B?
You can't do that. You can't put 1 over a matrix.
Yeah, you can't divide with matrix. But you're so close. You have the right idea. But in matrices, we can't divide, but we can do something else.
We can multiply
By
the inverse.
inverse. Yes.
Oh, okay.
Yes. Multiply by the inverse. So here's what you're going to do. If you want to do it this way, if you want to do it with matrix multiplication, tell me what you would find the inverse of.
B.
B. So find the inverse of B. Times C should give you matrix A. Okay, so let's try it. Put matrix B in your calculator, and then just immediately find the inverse. And then multiply it by matrix C. And then you should get A. Caitlin, you already have it?
Yes.
Tell me what it is.
-1, 2, -3.
Okay. Let's try it. If it works, then we will be able to multiply B times A and get C. See if it works. Okay, so step by step. Do you understand how to get it to this point, like right here? Okay. You would take matrix B and find its inverse, and then multiply it by matrix C, and that product will be what you need to find, matrix A. Got it? Put in your calculator 0, -8, -1, and -3 as matrix, whatever you want to call it. It doesn't matter. And then find its inverse. And once you get that inverse, multiply it by matrix C. And it should give you the answer to this question. And then you can check it by working backwards. But my question is there a way to set up a system? You have to do it twice, but there is a way to do it like that. So could I do this? Could I do 0, -8, try it. Try this. 0, -8, 16, -1, -3, and 7. Put that in your calculator and do RREF and tell me what you get. Put this 2 by 3 in your calculator and do RREF, bless you, and tell me what you get. Put this in your calculator and do RREF and tell me what answers you get. -1 and -2. So basically what I did is I set up a system to solve for the first column. Because that's the answers to the first column, right? -1 and -2. Now you got to do it again, though. And this time you do it with 8 and 1. And you should get the second column.
My brain's confused.
Wait, Miss Thomas,
Yeah.
couldn't you figure out all 4 though by doing it in one big 4 by 3?
Try it. Where's your 4x3 coming from?
Well, I mean, you can have like, you can have a 4x3 set up as like, you have that one, and then just stack it on top of like 0, -8.
Okay, why don't you do this? Call out the matrix you want to try.
Okay, it's a 4x3, and then you have 0, -8, 8.
Am I going across?
Yeah, 0, -8, 8, and then you have -1, -3. And then you have 0, negative. No. You go down the road.
Oh, another row.
Yeah, 4 rows.
Oh, 4 rows. Okay.
Yeah, that should work because that's how I use it.
And then you have 0, -8, and then what was the go back up.
16, I think.
Yeah, 16, and then you have -1, -3. And what was the other one?
7.
Yeah, so you can just solve it all at once.
That would work. Try it.
Wait, and that will give you
Try it.
A?
Try it. So, Kamal says try to set it up as a 4x3. And we'll go back up and look and see where he got those numbers from.
It was like number 0.
Let's see if this works, Kamal.
Oh, yeah.
Did it work? No. Why won't this work? So let's go back up here and look at where you're getting all these numbers from, though. You had 0, -8, and 8.
It's kind of like asking for the function to put out 2 different values.
Exactly. And the calculator, no matter how fancy your calculator is, it can't put out 2 different rows at one time. When you're solving a system, you're solving for it this way, vertically. So an X and a Y and a Z, like in number 10 in WebAssign. So if you want to use a system of equations, you're going to have to do one matrix for the first column and then reset it up for the second column. You can't combine it all together. Okay, that's a good try. You can't learn unless you try, right? All right, so you've got really 3 options. Finishing up WebAssign or working on these 2 worksheets. And again, the keys are right here if you want to come take a picture so you have it right now until I get it loaded. Okay? If you were